saying that so that I actually remember.
This conference will now be recorded.
Okay. So I'm Jean Marie Biesigal, the Department Chair of Integrative and Functional Nutrition, and we are here tonight to be presented with some wonderful, very timely information and science from Professor Lori Taylor. Just a little bit of background on Lori. Lori's been with Saybrook well over 3 years now, teaching at Saybrook. Lori has over 25 years of extensive experience as a registered dietitian, practicing in patient care, practitioner education, and healthcare consulting. Lori has a bachelor's degree in biochemistry from UC Berkeley, a master's degree in education from Stanford, and a master's degree in nutrition from Bastyr. She has extensive expertise, some of which include nutrition and environmental concerns, such as genetically modified foods, nutrition and autoimmune disease, metabolic nutrition, expertise in nutritional oncology. She is a dietitian. She's a member of the Dietitians in Integrative and Functional Medicine practice program of the American Academy of Nutrition and Dietetics. She's also had training from the Institute of Functional Medicine. She's a core faculty member in the Department of Integrative and Functional Nutrition here at Saybrook. She's also a member of the Faculty Senate and helping to lead the shared governance initiatives in the university. And Lori has been instrumental in really initiating the Masters of Science here in the Integrative and Functional Nutrition, growing the program, helping to graduate many of our successful students, and now leading it into the development of the PhD program. So without further ado, I think I will pass it over to Lori to educate us on the science and application of ketones, ketogenic diets, and intermittent fasting. So again, if you have questions, you can type them into the discussion board, or you can hold them until the end, or into the chat box, or hold them into the end, and we'll address them at the end. Thank you.
Thank you, Jean Marie. It's so nice to get introduced. Remember all the things that I've studied and all the great people that I get to work with. So my name's Lori Taylor. I'm going to talk tonight about the biochemical process, not too terribly in detail on the biochemistry of under what conditions we make ketones, what they are, and 2 ways that we can make ketones. That is a ketogenic diet and through intermittent fasting, and the benefits and risks of both of those types of practices. All right, now let me see if this is going to work tonight. There we go. So Jean Marie already gave you my background. So really tonight we'll try to focus on the evidence. There is building evidence for ketogenic diets and building evidence for intermittent fasting. And so you should be able to describe how those diets work and how they can help us and what are some of the side effects. So just starting off about what ketones are. So ketones are another way that we can use energy, and it's a way for our bodies to convert energy stored in our fat tissue and some from the protein, either in our bodies or that we eat, into energy. This happens when there are times where we don't have food or we don't have carbohydrates. And it was a pretty normal part of life for humans in between meals. The whole 3 meals a day structure that we have culturally is a cultural construct related to a farming economy. When you look at Paleolithic man, hunter-gatherers, there was not the frequency of availability of food. And so food would either be available, small amounts or large amounts, and then not available perhaps for a long period of time. So the body had to adapt, and humans were selected for those who could adapt well to times where there wasn't any food. So we typically make ketones in the spaces between eating if they're long enough, or if our carbohydrate intake is low enough. We used to, and when I was first a dietitian years and years ago, people used to confuse ketosis with ketoacidosis, and people thought ketosis was dangerous. Ketoacidosis is a totally different scenario where ketones are made because a patient with like type 1 diabetes can't get insulin into their, they're not getting insulin to unlock their cells so that glucose can get transported in. So the inside of their cells think they're starving, their bloodstream is full of glucose, they make a bunch of ketones because biochemically they think that the body thinks it's starving. The ketones and the sugar all hit the blood, it's too much for the balance of the blood. So there's a lot of ketones and sugar urinated out, and people get dehydrated and the concentrations go higher, and it's a very dangerous state. But this really only happens with people who are type 1 diabetics when they don't have insulin or they get really ill and they don't eat and their insulin and their food isn't matched. So the acidosis part comes from the fact that ketones are acids. And so when there's a lot of them in the blood, they lower the blood pH, and the body does not respond well to having a lowered pH. It's a very, very narrow pH range. So ketosis is just the process of making ketones. Ketoacidosis happens when metabolism goes awry in a sick patient with diabetes, and they have so many ketones, their blood pH is lowered. So it's not really something a healthy person has to worry about. This is from one of the major articles about benefits of the ketogenic diet for weight loss, and talks about looking, and here you can see that the difference between a ketogenic diet and ketoacidosis is, here you have no insulin in the case of ketoacidosis, where you do have normal levels of insulin either on a normal diet or a ketogenic diet. pH is normal between these two diets, and here you see the pH start to go lower in ketoacidosis. What's important to notice here, and you'll see this coming up later, is the level of insulin. So if you look at the difference between a normal diet, which is typically a carbohydrate-containing diet, and the ketogenic diet, which we'll talk about more in detail, which is a very low carbohydrate diet, you'll see that there's a lot less insulin secretion because there's a lot less carbohydrates to manage. So you see lowered blood sugar, lowered levels of insulin, higher levels of ketone bodies here. Those at that level can all be metabolized, and the pH about the same. So ketosis in itself is a safe condition. There's some question about whether it's prolonged and it goes on a long time if it's good for the body, but definitely in terms of looking metabolically at blood sugar, insulin, and pH, ketosis is a safe state. So we don't need to confuse the two anymore. So ketones, as I said, have some benefits. They help us stand times when there's no food. And because ketones are made primarily from fats, they save us from breaking down much of our muscle tissue to make glucose. So when we're starving and we don't have food, initially you will break down any protein that you've eaten, or any protein in your muscles will be converted to glucose through a process called gluconeogenesis. But the body will only allow a certain amount of that because you can't be using the muscle that it takes to get your body around to find food, or that it takes for your brain to remember how to find food, or that it takes your immune system to protect you from disease. So there's a shift over when you haven't had food or carbohydrates for a while, and typically that's somewhere in the 12 to 18 hour range, usually 18 hours or greater. You will start to make ketones primarily from your fat tissue. And the interesting thing is that once you make those ketones, they actually help your brain work a little better. They help you suppress your appetite, so you're not thinking that you're really, really hungry. And because of their biochemical structure, there's less oxidative stress when they're broken down because there's less oxygen consumption slightly. And for some people, depending on how long the state goes and depending on their own metabolism, there can be fat loss and weight loss with ketones. So I find it interesting that in these times for a Paleolithic man, between meals, even the biochemical state of ketosis would help them be able to focus on finding food and being able to operate. So they do have some real benefits. And when we get to some of the health benefits more in detail, you'll see that when you look at sharpening the brain, there's a lot of benefits in degenerative diseases of the nervous system. So when we look at the science, one of the things to remember is that ketosis isn't just one thing. And when we do studies, we try to reduce our variables to one so that we can attribute whatever changes we see to that one variable. It's very hard to do because that's not typically how living organisms work, and we have to design, I'm not sure what happened there. We have to design some very specific studies in order to isolate to one variable. But when you have ketosis happening, there's two things going on in the body. You have reduced the amount of carbohydrate intake. So you're reducing the effect of all that carbohydrate on your GI tract and all the organisms that live in your GI tract, called your microbiota, that would be using that carbohydrate, and the carbohydrate that is glucose that your body would be using. So you have less of that. So you have less insulin, which is the hormone that helps you manage your glucose levels in your body. And you also have a production of something new, the ketones, that are not produced when you're typically eating anything with carbohydrate in it. So it's important to know that when we're looking at these studies, sometimes the benefit of the diet relates to lack of carbohydrate, lowered insulin, because insulin is a hormone that affects the entire body. And sometimes the benefits of the diet are related to the presence of ketone bodies, and sometimes it's both. We can't really tease them out. We can sort of hypothesize, but it's two things, not one thing. So I put this slide in here because I'm a beekeeper, but for years we thought royal jelly was something special, because royal jelly is what is fed to a brood, like a baby developing bee, to make it into a queen bee. And so we thought that there was something special in royal jelly, and you've probably seen supplements that you can take that have royal jelly. And what the science actually found out is royal jelly is actually lacking something. It's lacking a suppressor. So all of the other baby bees are being fed something that suppresses them becoming a queen. I think there's a little bit of noise on the line. I'm not sure if I hear a clicker or something. I don't know if folks can mute themselves. So in terms of the royal jelly, I think about that, and that it's not what it has, it's what it doesn't have. So with ketones, the benefits might not just be from the ketones, they might be from the lack of carbohydrates. So we just don't know. But it's important to remember that ketosis is the result of two things. So we talked about the two ways to make ketones. We'll go into those in depth. So there's a diet, a specific diet, that's called the ketogenic diet, where you have a very low carbohydrate intake, or you can have intermittent fasting, where you have periods of normal eating, and then long periods of not eating, in which you are able to make some ketones. But the common mechanism is the body is not receiving much in the way of carbohydrates. It's so odd for it to be so quiet up there. Okay. So looking at the ketogenic diet, you'll hear people say they're counting their macros. So they are looking at the proportion of macronutrients by their calorie contribution. So ketogenic diet is not a high protein diet. It's a high fat diet that is adequate in protein and very low in carbohydrates. So you will see literature vary on how low the carbohydrate level has to be, whether it's 20 grams or maybe at the top 50, and all of that will depend on the person's metabolism. Some people metabolize carbohydrates very differently, so there's not an exact level at which ketones are made, but it's in that range. Here it's expressed as 5 to 10% of calories as carbohydrate. So the reason that a ketogenic diet is not a high protein diet is that for the most part, our protein can be converted into glucose by that process called gluconeogenesis that I mentioned before. So when carbohydrate intake is low, the body would prefer to use carbohydrate before ketones. So it will break down either dietary protein or body protein, most of which can be turned into glucose. So one of the reasons you see people obsessing over their macronutrient intake is if this protein level gets too high, the body can make carbohydrates from the protein, and it can up the carbohydrate level enough that ketones are not made. So there's a lot of attention that is required to execute a ketogenic diet. And some people will use urine strips or ways to check their pH to see if they're making ketones, to see if the diet that they're eating is actually producing that state. Because when you produce a certain level of ketones, they do spill over into your urine. So it's not a high protein diet, it tends to be a high fat diet. So looking at what foods are allowed on a ketogenic diet, from the left here we have lower carbohydrate intake, and to the right there's some carbohydrate intake. So it's primarily fat, again, moderate amounts of protein. You see on this diet a lot of salmon, a lot of avocados, a lot of coconuts, and people tend to limit their vegetables to a certain degree because below ground vegetables, that is root vegetables, tend to be fairly starchy. So people are looking at emphasizing above the ground vegetables. But if you're looking at a 20 to 30 gram per day carbohydrate limit, sometimes with the ketogenic diet, people will end up limiting some of their vegetables because that would be the only source of any carbohydrates they're getting. And that can be a little problematic. So this is basically the span. So it's appropriate to notice what's not on here. We don't have any fruit. We don't have anything starchy. There's very little in the way of nuts, because even though people think of nuts as fat and protein, some nuts have a fair amount of carbohydrate in them. So there's a little bit of a discussion about which nuts and how well they fit in. But these is generally what you see here. And again, the protein has to be limited so that it does not contribute to overall glucose. So what does the evidence say? So there's really good evidence. In fact, when we first started studying this diet was in refractory epilepsy in children. Refractory means it doesn't respond to epileptic medication. So I'm not sure exactly how it was first discovered. There's a lot. Mark Matson, who's a scientist who studies intermittent fasting, talks about, not so far in our past that people thought when someone was having a seizure that they were possessed. So they'd often be shut up into a room for 24 hours, and lo and behold, their possession went away, very likely because they were fasting that entire time and got to be producing ketones. We do see some evidence for weight loss, improvements in cardiovascular disease and type 2 diabetes, but it's really important to remember that you're comparing a ketogenic diet in those studies to a low-fat, high-carb diet. And we really know that for most people with weight issues, cardiovascular disease, or diabetes, the diets higher in carbohydrates aren't beneficial. So there is evidence for their efficacy in weight loss, but what we're comparing it to is a very low bar. So it is an extreme implementation of a low carbohydrate diet. There's some emerging evidence for some types of cancer, especially really aggressive types, like glioblastoma, which is, a lot of people will throw whatever they can at that diagnosis because it's so difficult. But more and more we're seeing interventions in the realm of neurodegenerative diseases, Alzheimer's, Lou Gehrig's disease, Parkinson's disease, traumatic brain injury. And then also looking into some hormonal issues related to polycystic ovary syndrome and even some resistant acne. But that's all sort of newer evidence. We do know it's a fantastic tool for pediatric epilepsy, and it's not the first thing out of the box, because if you can imagine growing up as a child with epilepsy, not getting to have any fruit or candy or cake for your birthday, those kids have a very, very restrictive diet to be able to stay well. So that kind of diet is only initiated when we know that other interventions won't work. Because it's also very hard to maintain. It's hard to maintain for adults, and it's even more challenging for children. So when you look at the research, it's really important to look at what organism the research is done in. Rodent studies and human studies sometimes line up, and sometimes they don't. So when you look at blood parameters related to cardiovascular disease, ketogenic diets cause movements in all the wrong directions in rodents, but much better directions in humans. You'll see they have the opposite effect. Most of the other areas related to pancreatic function, Actually, here we see opposites too. You get worsening insulin resistance and worsening glucose intolerance, where in humans, you get a little bit better parameters around balancing your blood sugar. Hemoglobin A1C, a measure for blood sugar control in diabetes and prediabetes, goes down. Blood sugar tends to stabilize, be less variable. People need fewer medications. And this is really related, probably more likely to the intervention that people are receiving less carbohydrate versus the fact that they are making ketones. So always remember when looking at this data that two things are happening: lowered carbohydrate and insulin and production of ketones. When you look at obesity, liver function, kidney function, you do see, in general, a little bit of consistency here. So it's just remember when you're looking at studies, look at what organism they were studying and realize that does not always translate to humans. So issues to consider on the ketogenic diet that have nutritional concerns. Well, I'm just going to start a little bit at the bottom about compatibility with culture. So, carbohydrates as a staple food for a lot of cultures around the world are really linked with civilization. When we started having agriculture, when we started cultivating, we could store carbohydrates over the winter. We could dry them. We could, they have rice and grains and can make bread and do all sorts of things to stretch those calories and to span the winter time when there is really no fruit and where the fertility of animals, they're all, hunkered down for the winter and may be more difficult to find. So this, having carbohydrates in the diet was how humans were able to establish civilization in advance, to have that base of calorie dependability. So many, many traditional dishes are based on, in some way, inclusion of starches. And that can make it really difficult for patients or people wanting to take on this diet to make a shift. You've probably had this experience if you've gone to a restaurant. Perhaps if people are intolerant of wheat, you've noticed how much of the culture is organized around bread. So to make those changes really means you have to have the access to make a lot of things yourself. You're also buying more high-quality fats, and fats are high calorie density, and so they tend to be more expensive and more resource intensive. So not everybody can access the cost of being able to buy salmon and avocados and coconut and high quality green vegetables. This diet can have some access issues related to income and also related to ability to find stores where you have those things. The environmental impact of the diet, when you're looking at eating more animal protein, and it might not be much more, but there's a real focus on it because it's very hard to do a vegetarian diet with a ketogenic diet. And this is because the vegetarian sources of protein, that is mostly the legumes or the protein that we get from grains, the legumes have carbohydrates, have a starch in them, so they would not be suitable for a ketogenic diet. So those would have to be removed from the diet. Grains would have to be removed from the diet. And you're really you don't really see concentrated sources of protein without carbohydrate except in animal food. So what it means is that there is a commitment to eating animal protein on this diet. And we do know that the environmental impact of animal proteins is higher than plant protein. So there's that effect on it. When you look at acidity or alkalinity based on the foods that you're eating, you are eating more plant foods, and those tend to provide a more alkaline environment when broken down in the body. Fat is fairly neutral, but animal protein is more acidic than plant protein. So there is a little bit more of an acid load from what you're eating, and the creation of ketones themselves changes the blood pH, so your body has to keep that in line. So the way we excrete acid is through our kidneys. So this can have an impact on the pH of urine. I'm kind of going backwards here, but really most important is the fiber content of the diet can be very low unless it's closely shepherded. Because people spend a lot of time looking at their macros and keeping their carbohydrates low, the above ground vegetables do have small amounts of carbohydrate in them. And so when that part of the diet is carefully watched and restricted, there is the risk that there might not be sufficient fiber. So other sources of fiber in the diet that tend to be where on a normalized diet or on an omnivorous diet, you get them from fruit, you get them from whole grains, you get them from legumes. Here now you're just getting pretty much the entirety of your fiber intake from vegetables. So all the above ground vegetables aren't always high fiber vegetables. It just depends. So depending on how this diet is executed, it can be low fiber or moderate fiber, typically not high fiber. There are some really funny ketogenesis or ketogenic diet memes out there. There's one that says, I'm not always in ketosis, but when I am, I don't poop. So one of the things that happens with a ketogenic diet is because of the low fiber content, GI function is not great. Sometimes the flow of the GI tract doesn't, you don't get good transit of your food. The second part of that is we now know that the microbiome, that is the organisms that inhabit our GI tract, which are primarily bacteria. Then we have some archaea, which is an ancient type of bacteria, plant viruses, and some fungi. They are dependent on our fiber content, and they are most healthy when we are eating a good amount of fiber from a variety of fruits and vegetables. And so when that fiber content changes, that changes the makeup of what we call the microbiota of the organisms, and it changes the makeup of the microbiome, that is everything they make and that they do. So the fiber content in a ketogenic diet really has to be carefully monitored. And I would say for anybody doing it, if they're counting macros, I hope that there's a place in a way in there to count fiber, because that, 25 grams for women, and I can't remember the exact amount for men, it's over 30 grams per day. It would be challenging to achieve that on a ketogenic diet and would take some real focus. So we might have talked about a few of these things. There's not a lot of research for long-term use of the ketogenic diet, and also not clear how sustainable they are. So people may get results. They may go through a long time of where they have a very low carbohydrate diet and get to the end point of what they want to achieve. And then sometimes we'll have a regain because they go so far off their diet because of all the things they miss. So this is a high force dietary intervention, meaning you are really focusing and changing the diet to an extreme degree to be able to make a metabolic shift. That acid in the kidneys, that the kidneys relieving the body of acid production from ketones, can also shift bone density because the acidity of the blood and the acidity of the organs can relate to, we may be pulling nutrients, minerals specifically in to neutralize that pH to some degree. So there are really concerns that the acidity of a long-term ketogenic diet would affect the bone. Some people talk about a keto flu when they either go on the diet and after a couple of days of a very low carbohydrate diet start to feel really sick and flu-like, and then some people will say that that happens to them if they're on a ketogenic diet and they mistakenly eat something that is higher in carbohydrate. So there's a period on this diet, at least, of adapting to it where people can feel really rather unwell. Talked about the variety issues. Being high in fat is an important thing to think about because fat is of all the macronutrients, fat is the hardest to digest. And for anybody who's got underlying digestive problems, there may be parts of this diet that are helpful, but the higher amount of fat in the diet does make it digestively challenging. When you're looking at a patient who has malabsorption of nutrients, the first sign of malabsorption in someone is the intolerance to fat or the inability to absorb it. Typically, we digest and absorb approximately 95% of the fat that we take in as far as food. And because of its difficulty in digesting it and absorbing it, because you have to make the fat water soluble in order to be able to transit within the body, the first time anybody has a problem with malabsorption, you will see it with relationship to fat. And people might also know the feeling of when you have a high-fat meal, you will often feel, you might feel kind of, you'll get full, but you might really feel like, well, I've had too much to eat, because the body knows that fat is difficult to digest. So when you get a certain amount of it in your GI tract, your body releases a hormone to slow the movement of your GI tract. So fat's harder to digest. So when you eat a lot of it, your transit of your food through your GI tract slows down. And so someone with some digestive challenges may not do well in this diet. So I added a little bit to this presentation regarding the microbiome. So how does a ketogenic diet, what does the research say about how a ketogenic diet affects the microbiome? So this is just a generalized slide from the British Medical Journal about what kinds of inputs, how they affect the microbiome. And the darker color means they contribute more to disease, and the greener color more to health. So if we can identify a few things off here about the ketogenic diet. We do have more of this TMAO production. When you're eating meat, the bacteria can metabolize some of the components in meat to make this inflammatory compound called TMAO. LPS is a protein, it's a lipopolysaccharide, so it's a fat and sugar molecule that sits on the outside of some bacteria. And when we eat a high-fat meal, it can be absorbed and enter the bloodstream. And this LPS is a trigger for inflammation. So normally it's just acting at the gut level. When we absorb a lot of it, it can set off inflammation at different sites throughout the body. Now, it's a condition called metabolic endotoxemia. So we would have more in these areas here. Depending on the fat profile, some of the fat is saturated. If you're eating coconut oil or animal fat, that tends to not have the best effect on the microbiome. We do have basically no sugar, so that's helpful, and typically not excessive protein consumption. So we're cutting out a few things here. The pH doesn't matter quite so much in the GI tract because the pH of ketones affects the bloodstream and not the GI tract. We do have lower fiber, so that's a negative. Let's see. Depending on the plant food intake, depending on the vegetable intake, depending on the plant food intake, if it's low, you won't have a lot of antioxidants. If it's as high as it can be to stay within the ketogenic limits, you'll do fine. Insulin sensitivity is improved because you're not having as many refined carbohydrates. You're not having really any carbohydrates other than fiber hit the gut. So there's pluses and minuses to a ketogenic diet from what we would be able to predict. So what the research says is mostly in mice is that you do get more of the beneficial bacteria with a ketogenic diet, probably because the less beneficial bacteria feed off of refined carbohydrates. Interestingly, you see in mice not so much diversity in the bacteria, and we know diversity of bacteria, just like diversity of people and diversity of energy sources and diversity of economies, we know diversity is beneficial, that it's resilient. So you do see less diversity with a ketogenic diet. In infants, they did some studies in epileptic infants, and you do see the beneficial bacteria increasing and the pathogenic ones decreasing. But what's really interesting to look at is that in those infants, they actually start out with more pathogenic bacteria in their GI tract than healthy children. So the question becomes how much of their epilepsy is related to the microbiome and how much of it is related to their genetics. It's probably both. But a ketogenic diet did restore some of the balance into the more beneficial organisms. When they went more deeply in mice, they actually found out that these changes in the types of bacteria were changing how neurotransmitters were modified in such a way that the ketogenic diet offered some protection against epilepsy. So to me, that's new research this year in 2018, and that's fascinating, saying that it's not just that we're making ketones in the bloodstream. This is before that. the effect of this very low carbohydrate diet on the microbiome is such that it causes the microbiome to shepherd the nervous system to be protective against seizures. And that's really powerful to think about when you look at this is before the ketones hit your bloodstream. Ketones also have their own benefits on the nervous system, but to me that's just fascinating research. And if you remember back here when we're talking about this LPS, this lipopolysaccharide that's on the outside of some gram-negative bacteria, when we have a high-fat diet, more of that can be absorbed and it can be inflammatory. So this has always been a concern of mine with ketogenic diets. And there's one study in mice that's showing that the ketogenic diet itself, even when they gave mice this LPS and they injected it, something about the diet helped decrease the inflammation and the fever related to that. However, the essential fatty acids, omega-3 and omega-6, were lower in the blood of mice. So essential fatty acids are needed for resolution of inflammation. So it's showing some mixed results in mice, but we're not seeing as much of the endotoxemia effect as we thought we would with a high-fat diet. So this just brings us back to that first point, that ketogenesis, the ketosis, the condition of having ketones is really two things. It's first, the predecessor to it is lowered carbohydrate intake, lowered insulin levels. And then we're looking at production of ketones. And a lot of what we're looking at here with the microbiome has to do with the first part, the lowering of the carbohydrates, because the liver has to make ketones. So this is the first passive effect of a ketogenic diet, really saying refined carbohydrates, large amounts of carbohydrates outside of fiber aren't beneficial to the GI tract. And this is just a paper from Cell just showing how you go from the diet to the microbiota to what's being made in the lumen in the colon itself, how that shifts to what's in the blood, how that changes what's sent to the brain, and then how it ends up with protection against seizures. It's just fascinating research. Now, I wanted to say here, a lot of people think that ketosis is a normal state for humans. It's what nature intended. So Chris Masterjohn is a fantastic biochemist who, if you ever want to learn more about a topic in biochemistry, he has it all dialed down into some very specific videos. So if you wanted to spend 30 minutes on a specific part of the Krebs cycle and listen to someone tell you about it, he's fantastic for that. This is a quote from his talk about ketogenesis is not a normal state in terms of for long term. It was really meant to bridge us between meals, and it's not how humans were meant to live. So his evidence for that has to do with some of the Inuit cultures. So let me just see reiterate what he said here, that ketogenic diet is a biohack of our metabolism. When we can't look at this from the foundational perspective that this was the ancestral diet of humans. It wasn't, and when evolution responded swiftly and strongly when the environment imposed that kind of diet as a permanent fixture. So looking at the Inuit diet, Inuits are native peoples that lived in Greenland. I want to say, I have to remember, Greenland is icy and Iceland is green. I remember that. And in that culture, there really aren't any, the amount of plant food that people had access to, it's a frozen tundra. There's not above the ground, or really probably even much in the way below the ground. Those cultures are depending primarily on marine protein and fat sources, right? So you would think it's a no carbohydrate zone, right? People would be in ketosis all the time. Well, what happens is that the people who survived and evolved because their bodies don't do much in the way of ketosis. They have an Arctic variant of one of their genes, and what it does is it shuttles their fats to be completely oxidized rather than to make ketones. And so what we find now is that babies in those cultures with that genetic background have to be tested, because if they're sick when they're infants and they have to fast because they're not eating, they cannot make ketones and they'll die. So these children have an increased risk of sudden infant death syndrome. So we think what happened and why people evolved in this no carbohydrate environment, why they really don't make ketones, is that ketones can lower the pH of the body, and they are a challenge to the system. And when you're living in the Arctic, that's already a huge challenge to the system. So it is important to note that this is evolutionarily, we could even say that being in continual ketosis is not the normal state, and when it needed to be, the environment selected for something different. So really, ketosis has to do with how we span long periods between meals. And are there benefits with that? Which the answer is generally yes. So we talked about epilepsy. If you listen to Mark Mattson talk, he's an aging researcher. He's a researcher who studies aging. And he talks also about the history of fasting, that a lot of people go on fast to sharpen and clear their mind, and that it's a part of many religious traditions to fast for periods of time. In fact, when you look back at some of the kosher rules for food, those have a religious meaning, but they also have a food safety benefit. So in the times before we really knew much about the biochemistry of things, a number of religious practices around food were meant to, with the knowledge of the time, preserve health. So fasting is one of those. So in fasting, you do produce ketones, but it doesn't require you to eliminate carbohydrates from your diet. And so more of the studies have gone toward looking at intentional fasting, because in this culture, we have, especially in Western cultures, we have there's a lot of food around. We're not typically worried about, for most people, where our next meal is coming from. I mean, we have a problem in this culture with food waste and excessive amounts of food, and we have ample access to animal protein and ample access to calories, ample access to carbohydrates. So if we're going to fast, it actually requires some intentional fasting. So there are three types of fasting that people do research on, and it's important to know when you're looking at the data which things you're looking at. Now, the kind that we don't do a lot of in humans is periodic fasting. We have 2 to 21 days of fasting. We do a lot of that in rats for longer, or you can fast rats for longer periods of time. It probably wouldn't pass most institutional review board protocols to engage in longer-term fasting in humans. There is some preliminary research in the safety of pre- and post-chemotherapy fasting for cancer patients, which is really quite promising. The rodent research is promising, and the first clinical trials about risk are also promising, but in those cases, we're looking at fasting for 48 hours prior to chemotherapy and ideally 24 hours after. But generally, you see the research come down in two areas: what's called alternate day fasting, or 5-2 fasting. Michelle Harvey, who's a dietitian in the United Kingdom, has done a lot of this work with women in breast cancer, I think women in diabetes, women in just generally weight loss. She's done a lot of research in women, and she's a dietitian, so I like to bring it up because we'd love to see more of that. She looked at having people fast 2 out of 5 days, and for her, even the fasting wasn't total fasting; it was a 60% reduction in calorie intake. So if your needs were 2,000 calories, that means you'd be eating 800 on those days. Sometimes they'll just tell people just no more than 600. So those 2 days are not in a row. Those 2 days people typically pick like Monday and Thursday. That way the weekends are not involved. They can do Tuesday and Friday. And overall, that represents about a 25 to 35% calorie restriction over the week. And I'll talk a little bit more about this diet. These diets tend to actually sometimes be easier than cutting out 25 to 35 calories of any given day. And they have a different metabolic effect. Then there's when most people are talking about intermittent fasting, they're actually talking about time-restricted feeding, when there's a certain window of time during a day where you would eat, and you would not eat outside that window, and that window would be fairly stable from day to day. So for some people, 10 a.m. to 6 p.m., and they're only taking caloric things in that window, which over a week's time ends up being about a 20% calorie restriction, or about 300 calories less per day, depending on which study you look at. So this is a part of Mattson Mark Matson, Michelle Harvey, Walter Longo, who's a longevity researcher from, I believe, UC San Diego or the Salk Institute, I'm not sure. They just are also trying to explain this in a diagram. So here's your typical American, three meals plus a snack. You can see that in a typical 3 to 4 meal a day program where you're eating it, breakfast, lunch, dinner, snack, sometimes people snack is in here, you're never making ketones. You're never getting to it because your blood levels of carbohydrate don't ever fall enough because you're eating frequently. This would be the 5-2 fasting. It says 1 day fast, but this is a little longer than a 24-hour fast. Typically when people do 5-2, as it's typically practiced these days, people don't eat from, let's say it's Monday and Thursday where it is, so Monday is a fasting day. You will not eat anything from dinner time Sunday night until dinner time Monday night. So it tends to be a 24-hour period. And you can see it takes until about 12 hours, and then your body will start to make ketones. And they'll peak at a certain point. And then once food is taken in, they drop again. And you can see the blood glucose getting high from the food that you've eaten. And as it gets absorbed and put away, it gets lower, and then your body maintains its basal level. So time-restricted feeding is, let's say I'm going to put, this is kind of an odd way to do it. It looks like they put their meals between like 1 and 8 or something like that. But you see these 3 meals clumped here. And you see it's from the last meal, it's going to be 12 hours until you make some, or more, before you make some ketones. So about 12 hours you'll start, and then the extended period allows you to build some up. It doesn't build up as high as during the alternate day fast, but what you find practically is that not everybody, some people will do better based on their personality or based on their biochemical individuality on one of these or another. I find for myself that I can do the time restricted feeding, but going the whole day is not great. My husband, who does the 1 day fast, says if he's okay as long as he doesn't have any bite of anything. He can make food, cook food, and he's a designer, and in these last hours of ketone production, he's very strict about when he restarts his eating because his most creative and best brain time is actually at the end of this. So he's actually trying to leverage this for design work. I'm going to kind of skim over these slides a little bit just so we have enough time for things. Effects of intermittent fasting on rats tend to, in general, improve the things we want to improve. They're less inflamed. Their blood sugar is better in terms of they're resistant to diabetes. Their hormones, insulin and leptin, so being able to balance your blood sugar and know when you're full, the receptivity to those hormones gets better, lower resting heart rate and blood pressure, and a lot of resilience in the neurological system. And if you listen, Mark Matson has a fantastic podcast through the Institute for Human and Machine Learning, I think is what it's called. And it really goes into the steps of how beneficial ketones are to the nervous system, and that they promote sort of the cleaning up of clutter from the cells, which is called autophagy, and how they enhance the production of BDNF, which is the brain-derived neurotrophic factor, which is a regenerative and nourishing substance for the neurons. But these periods of fasting on rodents improve their nervous system, and they improve sort of their overall metabolic resilience. In humans, we don't have as much research because you can't stick humans in a cage and control every aspect of what they eat. It's a little harder to do the studies. But there's some recent work that came out that looked at that intermittent fasting is good at promoting slow weight loss, slow, sustainable weight loss. It doesn't give these huge gains right away that the ketogenic diet does because it's not shifting fluid balance and it's not making these profound changes. But over time, it's producing some beneficial effects. If people exercise while they're doing intermittent fasting, it promotes retention of their weight and body mass. And people are able to stick to it because I've seen people try to hack what diet they eat in their eating window, but intermittent fasting will work no matter what you eat in that eating window, as long as you're not eating insane excessive amounts of calories. And because the eating window is closed to like an 8 or 10 hour period, usually it's 8 hours in men and 10 hours in women, you don't see, there's a limit to how much consumption there is. There's a GI limit to how much you can consume. So it's a very accessible tool as well, because if you're talking about someone who doesn't have a lot of means for different foods or specialized diets. We're really talking here about maintaining the patient's current diet and shifting just the times of the day that they eat. This is a figure from one of Matson's articles, just sort of showing overall that you see some beneficial effects in the brain. All the parameters that we want to see in the blood tend to improve. The liver's functioning gets better. The muscles are more sensitive to insulin. Here's this enhanced autophagy. Autophagy is that regular cleanup of our cells that our bodies do so that we don't hoard cellular contents and so that we don't have a lot of clutter. It helps us be able to move fast, reduce inflammation. It's a pretty fantastic way of improving body conditions. And you know, Americans really like extremes of things. You know, we're really fond of these very low fat with, you know, Ornish and Pritikin, and now we have this very high fat and very low carbohydrate. And what these intermittent fasting diets do is they sort of pulse the ketones into your system. You have sort of regular waxing and waning of how much carbohydrate you have and how much ketone. And it's actually that shifting of going back and forth, that little bit of challenge of having the ketones regularly that enhances the fitness of the organism. It's a process called hormesis, Hormesis, which is that small challenges to the body applied frequently promote health. So there's a real benefit to intermittent fasting in that it provides that challenge on a regular basis in a small way that's sustainable. So these are just sort of general prescriptions if you wanted to try intermittent fasting. 2 days a week. If you don't want to fast the whole 24 hours, you can eat one meal per day or a small snack. I mentioned, my husband's experiences, which is that it's sometimes easier to not eat. The time-restricted feeding, like I probably mentioned before, this is showing an 8-hour window here, saying don't eat between 6 p.m. and 10 a.m. or do eat between 10 and 6. Sometimes that's a 10-hour. It's metabolically for women, it does a little bit better if it's a 10-hour window, and that window needs to be adjusted based on what your work requirements are. So if somebody's doing a lot of physical work, they're going to think about, especially with their own bodies, do they need to eat close to that work or a little farther from it? It all depends on what it is. I know for me, if it's the morning time and I'm, typically my window would be like 11 a.m. to 7 p.m., but if I have to give a talk in the morning, I don't do intermittent fasting on the day because my brain's just not nimble enough for me at the end of the fasting. So it just depends on each person. So you have to experiment with moving that window, but it can't move from day to day because you have to have that hopefully 16 to 18 hour gap between foods. So you can't have your window be late one night and start early the next morning. And Matson, actually, when you talk to him, he's been practicing this for a long time. He's also a runner, so he's actually a super thin guy. He says that on the weekends he doesn't do time restricted feeding because that's when you're doing social things, and that 2 days on the weekend makes the 5 days during the week easier. So it's really interesting as far as a sustainable plan for shifting your carbohydrate intake. Who shouldn't fast? People in a growth process, so children, pregnant women, lactating women. Any restrictive eating pattern can be a trigger for somebody with disordered eating. Most athletes don't do well with this. I don't know if you follow the news stories about some of the World Cup soccer games being during Ramadan where there's religious fasting and people sort of having to adjust for that. Anybody who's got just sort of poor self-care, this isn't something you'd want to start with because it can just be a way of not eating or not eating well. I mean, wanting to make sure people are getting enough sleep and moving their bodies, before they start tightening up their eating window. And I say probably type 1 diabetics because has to be a real conscious control over blood sugar and insulin levels, and if those aren't matched, you can actually go low on intermittent fasting. But if it's, somebody who's got good control of their blood glucose and they're working with somebody whose specialty is diabetes. I had a patient early on in my career who was a type 1 diabetic, an engineer with a pump, and he went through a medically supervised fast of about maybe like a weekend every month, and he said that would correct the sort of chronic climb in his fasting blood sugar over the month. So if somebody has the type 1 that's going to do that, they need to be working with somebody who's really a specialist in type 1 diabetes and also who knows some of the concepts of intermittent fasting, because over time, high blood sugars over time cumulatively can cause macrovascular outcomes like cardiovascular disease, but all it takes is one really low blood sugar moment to kill somebody or put them into a coma. So it's really, for me, not a level that I'm comfortable practicing with. So I really want to make sure that people don't have type 1 and that generally their self-care is fairly good. So for me, I actually prefer the solution because of that hormetic effect of the small massive challenge regularly administered. Also, it helps us regain what's lost in the environment. We have food all year round. We can get strawberries in the winter. Typically, nature provided some of this carbohydrate control for us by only having fruits and starches half of the year and the rest of the year being pretty spare. So we don't have that anymore. We have carbohydrates all year long, unless you really, really work at eating seasonally, you're really not going to get that variation that would help us, actually put on fat. In the summer, your beach body would be actually the heaviest you would be, and then you would work off of that through the winter. You need to store your vitamin D in your fat so you can work off that in the winter when there's less sun. There's a whole cycle that we don't have anymore. And intermittent fasting can help us not be exposed to excessive amounts of carbohydrates. It's a way we deal with living in an excessive food environment without having to diet and count calories all the time. If we just have a window, it's helpful. Even if people don't exercise, there was a study done at the Salk Institute where people who had my classes before heard me talk about this. They made a phone app, and you can actually get it. I think it's called My Circadian Clock. And in that app, they had people record when they ate and what they ate by taking a photo of it and sending it to the researchers and within the app. And then the app makes what's called a feedogram. And what they found out in this research is that most Americans aren't fasting unless they're sleeping. Like, we're eating all times of the day. It's not just 3 meals a day anymore. And so what they did was their intervention back to this group of people was to say, don't eat after a certain time of night. They gave them an eating window. And I want to say it wasn't even that long. It was maybe 12 hours. It wasn't an 8 or a 10-hour eating window. And people lost weight and slept better just by changing their eating window. They didn't ask them to change anything else. So when you look at the fact that our diets, we have a lot of food waste, we've got more and more people on the earth, we have a problem with eating too much and wasting too much, this is also a way for us to be conscious about our food intake in a way that's not deprivatory and that actually promotes health and that anybody can access regardless of level of income. So, Matson talks about the doctor's office visit of the future where you get a prescription for one of these ways of eating. And then what you work on is improving the quality of the diet. So once we get the eating window established, can you eat more vegetables and fruit? Are you eating less processed food? So on and so forth. So my recommendations after having studied this for a long time, and I will give you the caveat that I have never done a ketogenic diet because it doesn't interest me to do something that restrictive for what benefit I think I would get out of it. So I tend to focus, because of my training in natural medicine, at lower force interventions first. So I would reserve ketogenic diet for specifically neurodegenerative issues and some cancers. It would not be my preference for weight loss for folks because we don't have the data to show that it promotes long-term maintenance of that loss. And it's a real hard thing to ask people to do. Some people do fantastic with it. It's just, for me, not a first recommendation. But you can, in almost all patients, help them make some ketones by changing the window in which they eat. And if they're now eating, let's say, people don't even get 8 hours of sleep a night anymore. They're getting 6, right? So they're eating 18 hours a day. Maybe they close that window to 12. It doesn't have to go down to 8 or 10. There can be improvements just when people have more time that they're not eating. Even the digestive tract works better, the flow of it's better, the cleaning process, the migratory motor complex works better when we're not throwing food on it all the time. And then just really look at improvements in the diet, more vegetable. I hate to see fruits come out because not only are they a source of fiber, they help us with our sweet tooth, and as human mammals, our milk has the most lactose of any other mammal, so we are primed to like sweet taste getting it as whole fruit not only gets us fiber, but it also gets us polyphenols, which are some of the most powerful anti-inflammatory compounds in the food that we eat. So, right now my students who've had me have heard me say that only 9% of people meet the Centers for Disease Control study requirements for sufficient fruits and vegetables, which are the dietary guidelines of 2 to 3 cups of vegetables and 1 to 2 cups of fruit per day. So really, when we're looking at our health and the health of our patients, whatever we can do to start getting them to even meeting those moderate goals is going to be beneficial, because it changes their microbiome, it reduces the amount of inflammation, and it tends to improve most of their metabolic processes. So intermittent fasting for overall health and slow weight loss, and then reserving a ketogenic diet for more serious conditions. So I am ready for your questions. Thank you guys so much.
Thank you so much, Lori. Wow. I definitely learned a lot. So questions from people.
Hi, Lori. Yeah, this is Kim Allen. Thank you. That was an excellent webinar. I have a question regarding intermittent fasting and diabetes and eating breakfast versus not eating breakfast. Where do you stand on that?
Right. It's interesting, because when patients have gestational diabetes, right, we know diabetes is pregnancy, which is just revealing, well, there's a little bit of an echo on someone's line there. Yeah. I think it might be Kristen. There is a, sorry, I'm going to have to mute it. A lot of feedback. Yeah. So, Kim, to answer your question, we know with gestational diabetes, which is sort of type 2 diabetes revealed by the challenge of pregnancy, that one of the primary dietary interventions is have a low carbohydrate breakfast, right? Because folks with gestational diabetes, because of some of the hormones of pregnancy, they'll tend to have their highest blood sugar in the morning. As to where I would stand for that with people with regular type 2 diabetes, I don't know. It really depends on what's their self-care like for the rest of the day. Is their food pretty reasonable quality? Are they eating with some frequency? They might do better waiting a little bit later, depending on what their morning blood sugar is, especially if it's on the higher side. If it's on the lower side, if their fasting blood sugar was like, maybe in the 80s, which is great for someone without diabetes, but isn't typical for someone with, I might think twice there. Do you have a specific situation or challenge you were thinking about?
No, thank you, Larry. Nothing specific. It's the debate that we hear about the importance of eating breakfast versus the IF world of not eating breakfast.
Right. I would say the breakfast is probably more important for someone with type 1 because of how they're trying to match their basal insulin and their meal insulin and so on and so forth. With type 2, it would just be worth, we know that let me back up and just say, the whole 3 meals a day thing is a cultural construct, right? And it really depends on what kind of medication are they using to control their diabetes. Are they using oral medications, or are they using insulin? Insulin complicates all of it. So I would be probably less likely to remove breakfast in the case of somebody using insulin, and more likely to experiment with it if they were just on oral medication.
Okay, thank you very much.
Sure.
Okay, CJ has a question, Lori. Oh, sorry.
Okay. Well, CJ, before we get started, I just wanted to say to Kim that this is part of the whole art and science of our field, which is that we don't really know. We don't have the evidence to say. It's just a matter of, clinical judgment and what's the evidence versus what's the risk. So, go ahead, CJ.
CJ. CJ, you're probably muted.
I'm sorry, I was muted. I was talking away. Okay, so Laura, you know me, and I have lots of questions. So let me start with some experience. And I think I've told some of you who are listening that I use the InBody 570, which is kind of a high-tech bioimpedance device. And it will give me quantification of total body water, muscle mass, and fat mass. And when I have individuals that want to go keto, I offer to follow them because I don't recommend keto diets for lots of reasons that you've described. So when I follow them, I find that they always lose total body water. They always lose muscle mass. And the fat comes off too, but it doesn't come off at a very significant rate. And published studies have shown that athletes who use ketogenic diets lose muscle strength. They show that they lose muscle mass. And at the end of a significant period of time, 6 months, 12 months, they don't lose any more fat than individuals that are just following a normally restricted calorie diet. So here I am going, same outcomes. Why do we go so cuckoo on something like this that, while it does have specific benefit in certain populations, as you described, neuro problems, etc., I don't think it's healthy for the general public. I have one client who lost a lot of weight, and I suspect he also was doing a lot of athletic supplements, and I'll put that in quotes because he wouldn't describe those to me. He is now in kidney failure. He has fatty liver disease and gallbladder problems that he's seeking treatment for. And I did not coach him through any of this. I just learned about it through his wife. So I missed the first half of this, but I do believe that when you are doing a high-fat diet, especially if you're not in a very controlled setting, where you think it's all the fat and meat you can eat, I know that's not a correct keto diet, but I think it's very detrimental for gallbladder function, liver function, and this guy only had one kidney. Genetically, he was born with one kidney and went into it with one kidney. So, I mean, we got a big set of problems, which I don't know, might be life-threatening. So I get real worried about this. And I'm going to put a semicolon here and say, when people tell me that they are keto-adapted athletes, that doesn't support itself in the published literature. So I saw a bunch of things at you.
Lead to a question here, just to move things along. I'm sorry. Is there?
So, Sita, did you have a question? Because I can comment on some of the things you said.
I just want you to comment on everything that I observe. I don't have a specific question.
I would say that when you manipulate the fat in someone's diet, whether it's Jenny Craig, which was times, or Pritikin, which is really low fat, or you go from really low to really high fat, you're really pressing the whole liver and biliary system, the gallbladder, to be able to secrete bile, to absorb all the fat, or you have a low fat diet and it's not getting secreted, so it's sludging up and precipitating in your gallbladder. Neither one of the extremes are really necessarily beneficial, and some people are going to be able to handle it and some people are not going to. This is why I refer to ketogenic diet as a high-force dietary intervention. And from the naturopathic, therapeutic order of naturopathic medicine, we don't start with high force. So it's funny that people want to go to a ketogenic diet right away, it being high force, and then you see those same people not wanting to go into medications and really intervention, invasive therapies, which are also high force. So you reserve those. In my way of practicing, and it's pretty consistent with what you see, is that it makes sense to reserve those high force situations, diets, and interventions for situations that require them. But also, I think we have a fixation as a culture with extremes, and so people really like the keto diet for weight loss because you see such a shifting in those first couple of weeks. If you look at somebody losing 5 to 10 pounds a week, let's just say 5, and let's just make it easy and say that each pound of, if it were all fat, would be 3,000 calories. So that's 15,000 calories. It's very, very hard to run a 15,000 calorie deficit in a week. And I know that it's not as easy as that, but we're just in general trying to put some numbers related to thermodynamics on top of it. Folks are losing water, and they're losing some muscle because the body will turn to gluconeogenesis first, and then losing some fat. So you're right in that it's shifting more than fat, and you never really want to lose muscle because you don't want to lose the tissue that keeps you healthy and metabolizes. So, you know, I do think it's overused and it's very popular right now, but I also think that there's some specific indications for where you would want to use it.
Right. And I think the dehydration part of it is very significant, and there's not a lot of science out there. I see it because I track it, but you know, if people are dehydrating, that's not good either.
Right. And again, remember that the weight loss studies are really comparing the ketogenic diet to a high carb, low fat diet, not comparing it to a more moderate carbohydrate diet, something along the lines of 40%. Kristen, I wanted to make sure I got to your question. And then CJ, if you want to ask another question after, if people have had a chance, that's great. And we can always talk offline too.
Yeah, thank you. All of that was fascinating. I actually have I've done the keto diet and found that it was great for clarity of thinking, but I was eating a lot of dairy, and that, like you said, like the meme that you talked about, that was my life in a nutshell, and where that's kind of been an issue for me in the past. I kind of determined that it wasn't the best diet for me to pursue. I'm excited to hear its relationship to ALS. I have familial ALS, or I don't personally. My father passed away from it. His sister, their cousin, his mother. So it's the familial type of ALS. And I wanted to ask, how much experience have you had with that and ALS and it being successful in postponing the development of the disease?
Sorry, I think there's a little feedback on your line. Just to answer your question, I don't have experience with patients with neurodegenerative diseases personally. There is a reasonable amount of research, especially in rodents, showing improvements in most degenerative diseases of the nervous system. Ketones tend to be healthy for the brain. So behind epilepsy and behind aggressive cancer, it may not necessarily need to be a ketogenic diet because the benefits are from the ketones themselves. So
right.
Intermittent fasting may actually be the best sort of long-term practice that provides resilience against neurodegenerative diseases. And even Alzheimer's disease is considered to be like type 3 diabetes, that is insulin resistance in the brain. So if you've got regular periods where there's fewer carbohydrates, that's an improvement.
I'm now on like a mainly plant-based diet, and I eat a lot of fish and meat, like maybe once a month, and chicken a couple times a month. But I try to stick to meat, to vegetables and fish. And I eat a ton of avocados, a ton of coconut. So I'm hoping that will, instead of doing a full-on keto diet, will serve me well, I guess. And I, obviously I don't know if I'm going to get it or have it or whatever, but I'm hoping
all of the microbiome effects. Hold on, I'm going to mute you because I keep getting feedback. All of the microbiome effects of the way you're eating, high vegetable intake, good fiber from vegetables, marine source, so fish, essential fatty acids, all have really, really potent anti-inflammatory properties. And so we have to remember that we can get obsessed with these macronutrient ratios, but really everything we eat is being translated for our bodies through these microbiota that live in our GI tract. And first and foremost, honestly, we have to satisfy them.
Yeah. I also, and like the past probably 4 months, I've been seeing a guy who kind of deals with stuff like this. I'm not sure what to call him, but I've done the apple cider vinegar and baking soda, and now I'm doing one for one with maple syrup and baking soda.
Kirsten, we're going to have to move on and move on to the next question. I'm sorry, just because I do know Lori has a community appointment that she has to make it to, so I want to address some other questions. But you can touch base with Lori about this afterwards if you're at another time. Thank you.
Thank you.
We have the next Kirsten, Lori. Kirsten Kleinman. Kirsten Nelson wants to know, she read a book about endurance training for athletes, becoming fat adapted, and she's curious about burning fat for energy and not being in keto. Kirsten, can you get on and explain your question? I'm a little confused about the latter part.
I can start with it. I think I know what she's getting at. Yes, I can.
Can you guys hear me?
You're a little low, but I can hear you.
Yeah, I mean, the book just basically had a lot of diet ideas and you were eating more fat, but it wasn't talking about being in ketosis. It was just talking about kind of changing your metabolism so that you were burning fat for energy instead of going towards carbohydrates so that you could essentially have more endurance and you didn't have to be eating as much for longevity while you were exercising. And I just, I'm a little bit confused of this idea of if you're trying to eat more fats and burn fats, are you in ketosis or can you just be burning fat as energy and not be in ketosis? Does that make sense?
Yes. So basically, if you're taking in any carbohydrate at all, right, of any reasonable degree, and you're doing high intensity or endurance exercise, even more so with endurance where you move more to burning fat and protein and less away from carbs. To burn fat completely to carbon dioxide and water requires you to have carbohydrates because those carbohydrates replete the intermediates in the citric acid cycle or the Krebs cycle. So it's often said that fat burns in the flame of carbohydrate. So if you're looking at, and Jean Marie is very experienced in sports nutrition, if you're looking at oxidizing fat completely rather than making it into ketones, that happens and it has to have some carbohydrates. So it may be looking at, keeping your carbohydrate intake to a certain level, not a ketogenic level, but a level enough to where you can support the complete burning of fat for endurance exercise. But, the thing is humans can compete in all sorts of conditions. And the individuality of each person and how their digestive tract works on either side of exercise or during exercise and how their specific metabolism works, it's not a uniform experience for folks. So I'm guessing that's what that book is getting toward is, a lot of endurance exercise relates to, you can see a lot of people doing Ironmans and so on and so forth, and there's intense exercise and there's endurance exercise, but you can see them sort of upping themselves with carbohydrates as they're exercising, and that's because those are much easier to digest. But in endurance exercise, it's not as high intensity. That is fueled more by fat, and so there may be some metabolic tuning that goes on there. But I don't, Jean Marie would know more because that's really more of a sports nutrition chunk of, that's their specialty, so to speak. And a lot of people are blending things. I have people like doing ketogenic diets while they're intermittent fasting. And, these are all our little experiments with it that aren't necessarily validated yet by research. And they'll probably be validated in rodents and not in people.
All right.
Yeah, I'd be
Thank
happy
you
to
so
talk
much.
to you
Yeah, that was very helpful. Yeah, that was very helpful. Thank you.
Yes, I do want to announce that the PowerPoints will be available, as will the recording. Other questions?
And I think we have time for about one more question.
Yep.
I had a question. This is Noelle. And
Noelle.
Hi. Just as you mentioned that it's a very popular diet right now, and there's not much understanding about it, do you have any kind of quick resources I could suggest to people asking me, so what do you think about keto? And don't necessarily want to take my word for it, because like you said, Americans do love extremes. So any resources I can point them towards that might help them out understanding more in depth about what they're getting into.
I don't know, Noelle, I don't know how the PowerPoint, I have uploaded the PowerPoint as a presentation and not a PDF. And in the notes section of my slides are most of the papers. There are some foundational papers, and I'm trying to remember the author's name. It's Paoli, Paoli, I think is one of the authors. But they're just some basic, what is the evidence for ketogenic diets, and really looking at it. Some of them explain, there's one called Ketogenic Diet, Friend or Foe. Some of just the basic science articles on it. It is, what you point to is what we find all the time in this field, is there's a lack of reasonable lay literature on these things. You'll see a million people writing on the ketogenic diet and very few people writing at a public level on here's the pluses and here's the minuses, here's where you should use it, that's why I developed this presentation, because we needed something for our program to be able to hold the ground and say, here's what we can say, here's what we know, here are the risks, here are the benefits. But, I always have people think about Atkins. Think about when everybody was doing Atkins. People don't really do Atkins anymore. This is kind of the new Atkins now, but that we go through these phases of extremes, and that extremes tend to not be sustainable in the long term. So I remember when I had my daughter, when kids don't sleep at night, you've heard of people putting their kid in the car and in the car seat and running around the block. And somebody told me something early on that said, don't do something one night that you don't want to do every night, right? Don't get yourself into those kind of habits. And so, if the ketogenic diet is what it takes to maintain weight in someone, do you really want to do that for years and years? Or is there some other more reasonable way? The problem is that the more reasonable ways tend to take longer to have an effect. But the effects last. So it just really has a lot to do with our personality as a culture of wanting a big result in a small amount of time. We have kind of a maturity problem about this stuff. I mean, people didn't get heavy overnight, but they want to get thin overnight. So,
thank you.
And so it's frustrating. I'm sorry there's not more out there. I'll see if I come up with anything. And are you in our program?
Yes, she is.
That's what I thought. I thought I've had you in a class before, so I can. If I find something, I'll send it to Jean Marie.
Yeah. Okay.
And I will post the slides and the presentation in the mentoring center. You'll probably all get a message about that. I do just want to address that, we obviously can't talk about this, the ketogenic diet for all of these specific populations, like athletes and epilepsy. That could be a whole nother course. So all of these are unique situations that we could have other talks about. So this is very general, and I don't think Lori's advocating for or against for any specific condition. There's, a lot to have further discussions about. So, and we're always here to have those discussions. So this was really, really helpful information, Lori.
And I would add, if you want to be watching your research, one of the most compelling things coming out of this research is looking at pre and post chemotherapy fasting. In the area of cancer nutrition, which is, I have a board certification in that, we're always looking for what's that thing that's going to affect cancer and not affect the healthy cells. In intermittent fasting, these periods of fasting prior to chemotherapy and after, they're just in the initial stages of research for safety and then efficacy. We see really, really promising results in rodents. But this may be that holy grail of something that affects cancer cells and doesn't affect healthy cells. So cancer cells have a differential stress response. They lack a differential stress response. So even in times of low food intake, they will continue to reproduce while normal cells will shut down. Well, there is a protective effect of fasting on healthy cells in this chemotherapy process. So the real question is, can patients tolerate the weight loss that will come from the fasting? And usually it's offset by the fact that they have fewer side effects after the chemotherapy and don't go through long periods of not eating. So if you want to really start to see where something is emerging and where you would use intermittent fasting is not as high force intervention as the ketogenic diet, but really that there's just keep the research on this is accelerating. So that's probably one of the most interesting places to take a look at what's changing for people and the most compelling use of some of these therapies. Thank you, Jean Marie.
Thank you.
Thank you, everybody.
Well, thank you, Lori. I really appreciate this. I appreciate everyone being here and asking great questions. And I hope everyone has a wonderful Thanksgiving.
Thank you, everybody.
Thank you. Thanks for coming.
Thank you very much.
Bye, everyone.